Chapter 1, Lesson 5 of Pre-Calculus. We're going to continue to look at functions and their inverses, and in this video we want to pay particular attention to domains. First we'll talk about how you determine inverses algebraically, and we did a little bit of work with this last year. You remember by definition in an inverse the x values become y and the y becomes x. So the way to determine the inverse algebraically is to simply take the algebraic function rule, exchange the x for y and the y for x, and then solve for y. So here we have this function f of x, which stands for y, is equal to 2x plus 3. To determine the inverse, we simply take this y value and make it an x, and we take this x value and make it a y, and then we would solve the equation for y just like we would any other equation. We look at then subtracting 3, dividing by 2, so the inverse of this function f of x, 2x plus 3, is x minus 3 divided by 2. So that is how you would do that algebraically. Now when we're looking at domains, the domain of the new function sometimes will inherit certain characteristics. And the reason is some functions are not one-to-one, but we do want to look at the inverse because it's important that we study the inverse. And the square root function, if we take a look at it, is the inverse of only part of the squaring function. In other words, if I have x squared here, you'll notice if we do the horizontal line test on this, the inverse will not be a function. However, if we limit the domain to only the values that are greater than 0, let me white this out here. If we only look at the domain values greater than 0, we'll notice that when we do the horizontal line test, the function will be, or its inverse will be, a function as we have it here. And the square root function is a function that we need to study and that has a lot of application. So by restricting the domain, that's going to then be inherited by its inverse. This restricted domain is going to be inherited by this inverse function. So we want to take a look at these inherited functions and the inherited characteristics of the domain. So this page kind of explains that. So what we're going to have to do in order to determine the domain of these inverse function is to consider the range of the original function or relation. So again, practicing determining the range, and then that's going to become the domain of the inverse, because again we switch x with y. And if you remember, x values are domains, y values are range. So if in the equation we make the y x and the x y, then the values that we put into those particular variables are also going to be switched. So the range values of the original function become the domain of the inverse function. It's inherited, and the domain of the original function becomes the range of the inverse function. So again, these are inherited, so we're going to need to determine the domain and range of the original function first in order to calculate or determine the domain and the range of the inverse function. So for an example, we have f of x is the square root of x plus 3. We want to determine the inverse and then state any restrictions on the domains of both this function, the original, and its inverse. So we want to take a look at this. First function is y equals the square root of x plus 3. The domain of this function are x values that are greater than negative 3 or equal to, and the range values are going to be y's greater than or equal to 0. Again, this is a square root function. Now to determine the inverse, we are going to switch this y and make it an x, and we're going to take this x and make it a y. But that means we're also going to do that for the domain. So this x value that's a domain value is now going to be a y, and this y value that's the range is going to become an x. So we switch every y and every x, even in the domains and the range. Then we're going to solve this equation for y. So we're going to square both sides, and then we're going to subtract 3. So our inverse function, I want you to notice the notation here. The inverse function is x squared minus 3. And again, I have to do that because you'll notice that if I just looked at this function here, x squared minus 3, well, that has a domain of all real numbers. There are no restrictions. However, because this function came from this original function, this inverse notation actually informs me of that fact. The fact that this x squared minus 3 is not a function that was just looking at independent of any of its original function, but actually this function came from another function, and that's why its domain is greater than or equal to 0 and not all real numbers, because it actually is inheriting this range value right here at the top. The original range was greater than 0, and when we changed it to its inverse, switching y to x, it now becomes the domain. So you see that this domain is inherited because the range values of the original functions were greater than or equal to 0. So again, the inverse notation is important because it indicates that this x squared minus 3 came from another function. If you simply put y is equal to x squared minus 3 and put the domain as this, that would lead someone to believe that this domain that you have is wrong, because this function shouldn't have any restrictions. So when you're doing domains and you're doing inverses, you're going to need to determine the domain of the original function, the range of the original function, and then when you switch your x and y values, you're going to switch the domain and the range as well. So let's do this one example where we have the f of x function is equal to the square root of x plus 2. We need to find the domain and then the inherited restrictions on the domain, if there are any. So again, before we begin, I would like to determine the domain and range of the original function, because we're just going to switch those when we get our inverse function. So the domain of this function, because it's a radicand, the domain is x is going to have to be greater than or equal to -2. So in interval notation, that's going to look like this, -2 up to positive infinity. That's my domain. And my range values are going to be y values that are greater than or equal to 0. So my range is going to be greater than or equal to 0. And if you have trouble remembering that or visualizing that in your mind, then go ahead and just graph the use your calculator to graph the expression, determine the domain and the range from there, at least the range. Then we want to find the inverse, so we're going to make this y value an x, and we're going to make this x value a y, and then we're going to solve this. So we're going to square both sides to get rid of the square root sign, and then we're going to subtract 2 from both sides, and then we're going to put the inverse notation on here to indicate that this function came from another function. So the inverse of this function is x squared minus 2. And again, if we were just to look at this x squared minus 2, we would think that the domain is all real numbers. But because it came from another function, it's the inverse of another function, we need to look back at its range and domain and take the domain from there. And again, we switch the y and the x. So this y, that's prime range, is now going to be an x. So this is now going to be my domain. So my domain of my new function is going to be numbers from 0 up to positive infinity. So my domain becomes the range of my inverse function. So that would be how you determine the domain of an inverse function, as it inherits the restrictions from the range into its domain as the inverse of another function.